Okay, today we are going to discuss logarithms of grade 10. Here we are going to discuss how to write a given index form expression in log form and given log form expression in index form, and we are going to check how we read a logarithm value using a logarithm table, and we are going to find the logarithms of relevant some values and the corresponding value of the given logarithms, and we are going to discuss some past paper questions. Okay, first of all, look at here. You have given a particular index form expression. Okay, here what is this one actually? 10 to the power of 3. You know how to read this. 10 to the power of 3 means it is a power term. This says that 10 has been multiplied repeatedly 3 times. Then we obtain 1000. Okay, then simply this can be expressed as an index expression, as an index form. It is how 10 to the power of 3 is equals to 1000. Okay, this is called the index form of a number. Now here it is 1000. Then we can say this is the index form of 1000. Then how we convert this into log form? This is called the log form. Log form is another representation of a number in index form. It is, we have to write a word called log, and we write the base. What is the base? Base is the number that we multiply repeatedly to obtain a particular answer. Then here we have multiplied 10 repeatedly 3 times. Then 10 is the base. 10 is the base. Then base in log form is written at the end of the G. Then within the, now actually we can say that here this is the base, log to the base. Now within the log term we write the value. Okay, then here in this case it is 1000. Here it is 1000. Then this is called the value. Value is written inside. Okay, this is value. This is base. And we read this one. This is read as logarithm of 1000 to the base 10. Logarithm of 1000 to the base 10 is equals to 3. 3 is what? 3 is here the number of times that we multiply 10 repeatedly. It is, now in this case it is 3. This is called the index. Then this is index. Now this is called the converting index form into log form. Now let's see, when you have given log form, this is called the log form. Log form. When you write a log form expression in an index form expression, the base is equal. Now base is written at the end of the letter G, then base is 4. Then 3, that means index is written as the answer of log form. Then index 4 to the power of 3, the value that we obtain is written inside the log form, then it is equals to the 4 to the power of 3 in index form. This is index form. Okay, you have given some exercises to do by looking at the above 2 examples. Look at here. Here it is 5 to the power of 3 is equals to 125. Now what is the base? Base is 5. That means log. Then base is written at the end of the G. Then we write the answer within the logarithm term. Then we write the index as the answer. This is read as logarithm of 125 to the base 5 equals 3. Then here, this can be written as logarithm to the base what? Now here, the base is a negative value. It is minus 4. Then what you have to write within the log term is the answer in the index form. It is 64. Then this is read as logarithm of 64 to the base negative 4 is equals to the index of the index form. It is 3. Then here it is log form. Then always from when you write a value in log form to index form or index form to log form, first of all identify the base. Base is 3 here. Then 3 to the power of what? Power, or the index is written as the answer in log form. Then 3 to the power of 3. Then the answer in index form is written within the log term in the log form. It is equals to 27. This is read as 3 to the power of 3 equals to 27. If so, what is the answer here? It is, now base, identify the base 3. What is within the, what is the answer in the log form? It is minus 3. Then what is the value inside the log form? Log term, then it is 1 upon 27. So this is read as 3 to the power of negative 3 equals to 1 upon 27. Then after, look at here. This is given in index form. Then to convert log form, log, we write the base at the end of the G. Then it is 7. Then answer in the index form written within the log term in the log form. Then index in the index form is written as the answer in log form. Then this is read as logarithm of 1 over 343 to the base 7 equals to minus 3. Here, this is very popular question actually, because some of the most past paper questions we can identify this one. Look at here. This is index form. Remember, this is the index form. Then actually if we discuss about this one, here 20 is the answer. That means when you find the value of the power 10 to the power of 1.301, answer is 20. That means when you write the 20 as a power of 10, its index is 1.301. Then when you write this in index form, log form, logarithm to the base 10, what we write within the log term? Now you know it is 20. It is equals to 1.301 because index is written as the answer in log form. This is the log form. Then how we read this one? Read this. It is read as logarithm of 20 to the base 10 is equal to 1.301. That means you can identify if you have found a particular log value to a particular base, it says that it is the index of the particular power when you write it to the given base. Okay, now in this case, the 1.301 means it is the index of the power 10 when you write 20 as a power of 10. That is the meaning of logarithm of 20 to the base 10. Okay. Then another special thing that you should know is the logarithm to the base 10 is equals to the LG. That means this is the short form of this term. Okay. Then if you have given to find the, now you may think that you have given 10 to the power of 1.301 equals to 20, and you are asked to find the value of this. What is meant by this one? That means same here. You have to write this in log form. It is equals to logarithm of 20 to the base 10 equals to 1.301. Then instead of this logarithm to the base 10, we can write LG20. It is equals to 1.301. That is what here they have explained. Look at here. Logarithm to the base 10. Logarithm of 4.55 to the base 10 equals to 0.6580. That means it is equals to, instead of logarithm to the base 10, LG can be written. Then LG 4.55 means logarithm to the base 10, 4.55. That means the same answer. Then when you ask to write this, that means particular log form given with the word LG only, that means you have remember its base is 10. Okay, this is very important part because you have to remember this in the exam. Okay, then look at here. They have given a particular practice exercise here. Let's see what are the answers. Actually, it is very easy. Let's fill this one. Here, logarithm of 357 to the base 10. It is written as, because you are asked to write it with LG. LG 357. Here LG 1250 means it can be written as LOG. That means logarithm of 1250 to the base 10. LG 25 means logarithm of 25 to the base 10. LG 84 means logarithm of 84 to the base 10. Then logarithm of 28.1 to the base 10 can be written as LG 28.1. Okay, actually this is very simple exercise to remember what we learn. Okay. Then in the next part, we have to learn how to find the logarithm value which is corresponding to a given value. Okay, here they have given a particular part of a log table. Look at here, we are going to find the logarithm of 4.55. First of all, we can write this in scientific notation. How we write? Scientific notation means writing a number as a product of a number between 1 and 10 times 10 to the power of, or a power of 10. Okay, this is the product. Then here 4.55 locating between 1 and 10. Then this should be multiplied by 10 to the power of 0 because 10 to the power of 0 means 1. Okay, then after you write this value in scientific notation, you identify what is the index. Then when you have to write a logarithm, logarithm consists of two parts, main two parts. What are the two parts? The value which is written as a whole number part is called the characteristic. And the value which is written as the decimal part is called the mantissa. Okay. Then the characteristic is obtained using scientific notation. That means actually we can use a simple method. Here you can identify how many whole number or how many digits are there in the whole number part. It is 1. Then you can subtract 1 by the value that we obtain here. That means the number of digits or the number of number of digits in the whole number part. Whole number part, subtract 1. Then we obtain the characteristic. Now here it is 1. 1 subtract 1, it is 0. So characteristic is 0. Then after, look at in the logarithm table, there are 2-digit numbers in the first column. Then you have given 0, 1, 2, 3, 4, 5, 6 likewise up to 9. And then after in the other columns, it consists of mean differences. Now look at 4.55. Then consider the 2-digit in the given number. It is 45. Then move to the 5. That means fifth column of 45. It is 6580. It is the mantissa of logarithm. With the characteristic and the mantissa, we can write the logarithm of 4.55 to the base 10. It is equal to 0.6580. Actually, what is mean by this one? Write in logarithm value to the base 10. That means it says that when we write it as a power of 10, that means 10 to the power of what? 0.6580 is equals to the 4.55. That means when you write 4.55 as a power of 10, its index is given by this log value, okay, or the logarithm. Then let's move to a exercise. Here you have given a part of a logarithm table. It is not past, actually it should be part. A part of a logarithm table to the base 10 is given above. Fill in the blanks given below using it. Okay. Here look at number. Number is 7659. Then count how many digits are there in the whole number part. Actually now it is a whole number. There's no decimal part. Then 1, 2, 3, 4. Now subtract 1 by 4. It is 3. It is the characteristic. And also this can be obtained as obtained using scientific notation, because when you write this in scientific notation, the number between 1 and 10 is 7.659. To obtain the same answer, this should be multiplied by 1000. That means 10 to the power of 3. Then here index is what? It is 3. It is also equals to the characteristic. This is the short way to obtain the characteristics, or other way you can obtain the answer using scientific notation. Then the mantissa. Mantissa is obtained by, first of all, you have to split this given number to, you have to take the first 2 digits as the first number. Then here it is the column that you have to consider. This is the column in mean difference you have to consider. Then 76. Then fifth column of 76, it is 88, 37. And you have to consider the 9th column in the mean difference. It is 5. And you have to add these two together. 5 plus 7, it is 12. 1. Then it is 88, 82. Then the logarithm of 7659 to the base 10 is equals to 3.8882. Okay. Then another number. It is 777.7. 777.7. Okay. What is the what is the characteristic? Here in the whole number part, 1, 2, 3. Then subtract 1. Answer is 2. That means in logarithm, characteristic is 2. Let's see whether it is equals to the tens power of when it write as a write in scientific notation. Here it is 777.7. Only 2 digits should be shifted to the decimal place. That means 7.777. Then only 2 digit was shifted to the decimal place. That means 10 to the power of 2. Yes. Then when you write this in scientific notation, its index is equals to 2. So 2 point. Then look at 77, 7th row, sorry, 7th column. 7. Then 77 here. This is the 7th column. That means 8904. In the mean difference, it is 4. Then add. 4 plus 4, it's 8098. That means mantissa is 8908. That means logarithm of 777.7 to the base 10 equals to 2.8908. Okay, another number is given. 217.8. 217.8. Let's find the characteristic using the short method. It is, you count the number of digits, 3, subtract 1, it is 2. That means characteristic of logarithm equals to 2. Let's identify. Yes, we have to shift only 2 digits to the decimal place. That means 2.178. Why we shift these 2 digits? Because to obtain a number between 1 and 10. This is multiplied by 10 to the power of 2 because we shifted only 2 digits. Now this index is equals to our characteristic. Okay, to obtain the mantissa, you have to check the 7th column of 21. That means, you have to add the value in the 8th column of the mean difference to the 7th column of 21. Let's see. 21, 8. 21 will 8 can 3,385. Then it's 7th column, no? 7th, oh sorry, it should be 7th column, 8. 7th column, 8. Then 3,365, 16 is added. Then is 3,381. 3,381. This is the answer of logarithm of 217.8 to the base 10. Then let's see this one. At once we can identify there are only one digit in the whole number part. So 1 subtract 1, answer is 0. Then when you write this in scientific notation, no need to shift any digit to the decimal place. That means 10 to the power of 0. Index is obtained as 0. So the characteristic is 0. Then check via the 7th column of 4th column of the 20. Move to the 20. 7th column 4. That means 3096 add 15. It is 3111. 3111. This says that when you write the value 2.047 as a power of 10, its index is 0.3111. Okay. This is about the finding the logarithm of a number. Then you can write that logarithm of a number which is obtained using a logarithm table to the base 10 is equals to the index of the power when the number is written as a power of 10. This is the meaning of finding the logarithm of a particular number to the base 10. Then what is meant by finding the value corresponding to a logarithm? That means in this case you have given the logarithm. Okay. Then finding the value corresponding to a logarithm means it is the anti-logarithm. Then here in this case you are given the logarithm. Okay. You have given the logarithm. Then you have to find the particular number corresponding to it. Then the logarithms values are located in the middle of log table. Then now in this case also you have to identify the particular values. Here look at where 6580 locate. It is located in the 45th row in the 5th column. Okay, so we write it as 45.5. Now you have obtained it as 455. Then how we separate this? Now it is separated by looking at the characteristic. Actually we obtain the location by taking the mantissa, and using characteristic we separate the whole number part and decimal part. Here it is 0. Then you can remember we subtract 1 from the number of digits in the whole number part. That subtracted number or the subtracted digit 1 is added here. Then characteristic it is given by 1. That means for the whole number part you have to separate only one digit. That means it is 4.55. When you find this one, you can write this as anti-log 0.6580. Okay, it is equals to 4.55. Then let's do an let's do an exercise. A part of a logarithm table to the base 10 is given above. Fill in the blanks given below using it. Okay, you have given the particular logarithm and you have to find the corresponding number. Okay, logarithm. Then identify the location of logarithm using Mantissa. It is 3347. 3347. It is close to this value, no? That means to obtain 7, you have to add 1 from here. Okay. That means it locates in the 21th row, 6th column. Okay. And you have to take 1 from the mean difference. So you can write it as in here 21, 6, 1. Then first of all write this in scientific notation. It is 10 to the power of 0. Okay. Then after, because here it is characteristic is this one. Now you can identify that it is scientific notation is 0. That means it should be 2.101. Or you can identify the characteristic is 0. 0 plus 1 is 1. Then separate 1 digit for the whole number part. Okay, this is how we do this. Then logarithm 8920. 8920. We are 8920. 8915 is located. It is in the 77 9. 5 should be added. No, that means it is 9. Then write it in scientific notation 10 to the power of 0. Then that means here it is number is 7.799. It's because now here if you consider the short way, the whole number part is 0. The characteristic is 0. Then add 1. Then for the whole number part only 1 digit should be separate. Here it is 3296. 3296. 3296. 3284 is located. 3296. 3284. Subtract 12. That means 12 is not enough. Then take 12 from here. It is in the third column of here 6, 3, 6, 21, 3, 6. 21, 21, 3, 6. It is multiplied by 10 to the power of 2. 2.136 is multiplied by 10 to the power of 2 because scientific notation, in the characteristic it is 2. Then in the scientific notation power should be 2. Then that means the number is 213.6. Or in other way, if you look at the characteristic, it should be 2 plus 1, then 3. That means in the whole number part, 3 digits should be separated. The last one, it is 3450. 34. Look at 3450. 3450. 3444 is there. 3450. Subtract 3444. 4 subtract by 10 is 6. Then 6 is not enough. Then 6, 1, 6, 22. 22, 1, 6. 20. 216 multiplied by 10 to the power of, what is the value here? It is actually, here it is 2. That means 2.216 10 to the power of 2. Then this, if you look at here, it is 2. Then 2 plus 1, it is 3. Then for the whole number part, 3 digits should be separated. Okay. This is the end of the reading a number using logarithm table and identifying the corresponding value to the given logarithm. By using this tool, let's identify how to apply the log rules and find the value. Okay, what are the log rules? There are 3 log rules that you have to learn. Okay, before I move to this, I will explain it. In the grade 10, you have to learn only 2 log rules, and in the grade 11, you have to learn another log rule. First one is logarithm of a product. Logarithm of a product. What is the logarithm of a product? You may think there is a product. xy is the product. Its base is z. Then this is separated by logarithm to the base z x is at logarithm to the base z y. This is called the how to separate a product of a logarithm. Then logarithm of a quotient or a division. Logarithm of a quotient. Actually, product means multiplication. Quotient means division. Then logarithm x divided by y to the base z. Then logarithm of x to the base z subtract logarithm of y to the base z. Okay, that means if you have a division, you have to subtract the log terms. The next one is logarithm of a power. Logarithm of a power. If you have given logarithm of x to the power of y to the base z, this y comes front of the log term. Then logarithm of x to the power of y to the base z equals to y times logarithm of x to the base z. These are the 4 log rules that you should know when you are going to solve the logarithm related question. Okay. Now let's see, by applying these log rules and using logarithm table to the base 10, how to solve or how to find the value or the answer for a given numerical expression. Here look at, it is given that 12.8 times 4.65. You have to find the value of 12.8 times 4.65 using logarithm table. First of all, you have to equate this given expression to an unknown term x. Here then it should be 12.8 actually. 12.8 times 4.65. Then the next second step, you have to apply the log rules. Apply log rules. Then here look at, it is a multiplication. Then these two values should be separated using addition. Or you have to take the sum of these two. When you take the sum, don't forget to write LG or logarithm to the base 10. Okay, actually here what we do is we first of all equate the given logarithm, sorry, given numerical expression to an unknown term. Then after we take the logarithm to the base 10 for both sides. This step is missing actually. This is what we do. Then when you apply this, it is logarithm to the base 10, 12.8, add logarithm to the base 10, 4.65. Okay. So then after, you have to find the corresponding log value of 12.8. Then what is the characteristic? Here there are only 2 digits. Then 1 subtract 1, it is 1. Then characteristic is 1. Then in the 8th column of 12th row, it is 1072. You can check it using the logarithm table. Here in the whole number part, there are only 1 digit. That there is only 1 digit. That means 1 subtract 1, it is 0. So characteristic is equals to 0. If you check the 5th column of the 46th row, it is 6674. That means mantissa is 6674. Then you can add these two. When you add these two, answer is 1.7746. Okay. Then to find the actual value of x, now actually here you have obtained is this one. මේක තමයි ඔයාලා මේ අරගෙන තියෙන්නේ. LG, that means logarithm of x to the base 10. To find this, you have to take the antilog of 1.7746. That means corresponding value to the given logarithm value. You can identify 7746 is located in the 5951. That means 5th column of 59th row. Then you have to add mean difference also. Then here characteristic is 1. So the power of the scientific notation in the 10th power is 1. Then when you multiply this, it is 59.51. Because here characteristic is 1. Then if you add 1, 1, it is 2. That means for the whole number part, 2 digits should be separated. Okay. Then this is how we obtain the answer for a particular given numerical expression using logarithm rules and logarithm table. Okay. There are some exercises. You can try to do this to practice the obtain the values using logarithm table. This is about multiplication. Let's move to the division. Now here, in this case also, you have to find the value of 52.8 divided by 4.65 using logarithm table. Look at, in this case also, you have to equate the given numerical expression to an unknown term. X equals to 52.8. It is divided by 4.65. Now take the logarithm to the base 10 of both sides. Then after, it is actually LG of x, because instead of logarithm to the base 10, you can use LG. Now apply log rules. When you apply the log rules, it is given here. Look at, you have to subtract. It's because it is a division. When you divide, we do the subtraction. Don't forget to write the each and every number with the logarithm, either using logarithm to the base 10 or LG. Okay, these two should be written using LG. LG දාලා තමයි මේ subtraction එක මේ මැදට එන්න ඕනේ. Then look at what is the corresponding value, logarithm value to the 52.8. Here it is only 2 digits, so 1 subtract by 2, it's 1, then characteristic is 1. In the 8th column of the 52nd row, it is 72226. Then here characteristic should be 0 because only one digit in the whole number part, then it is 0. Then in the fifth column of the 46th row is 66674. Then subtract. Then you have to check to find the x. Find x means this value. You have to take the antilog. Antilog means corresponding value to the logarithm 1.0552. Then here 0552 is located in the 11th row, 3rd column. You have to take the 7th column value in the mean difference. It is then 1.137 is multiplied by 10 to the power of 1 because characteristic is 1 no? Then it becomes 11.37. Or you can just write 1137 and when you separate using with the short method, here characteristic is 1, 1 add 1 it is 2, then 2 digits are separated. Okay. In this case, we do not write it as 1.137. We just write only digits and then after by looking at the characteristic, we separate the whole number part digits. Okay. In here also, by looking at the example, you can try to do these given exercises. Okay. Then obtain the answers. Using a calculator, you can check whether you have got the correct answers. Okay, here in the last page of this tutorial, they have given some past paper questions based on the grade 10 logarithm lesson. Actually, here most of the time you have to apply the log rules and converting log form into index form or index form into log form. Okay, let's see here in the 2011 the first paper part A 20th question, you have to find the value of this given expression. Okay, then let's see here 2 times LG5 add LG3 subtract LG2. Okay. Then here LG5, you can write this 2 as a power of 5 because by applying the logarithm rules. ඒ කියන්නේ මේ ඉස්සරහට ඇවිල්ලා තියෙන මේ 5 වල ඉන්ඩෙක්ස් එකනේ. එතකොට රූල් එක ඇප්ලයි කරලා එතකොට ඇඩිෂන් තියෙනවා නම් අපිට ඒව සෙපරේට් කරන්න පුළුවන් මල්ටිප්ලිකේෂන් එක. ඒකට I log ලියන්න LG ලියන්න. We write 3. When you have to subtract, it is divide by 2. Subtraction and division එක. එතකොට මෙතන අපට එනවා LG 5 to the power of 2 means this 25 into 3 upon 2. Sorry, here it is not 3 actually, it should be 8, okay? It is a typing mistake, it should be not 3, it should be 8, okay? Then here it is 8, 8, okay? Then 8 divided by 2, it is 4, 25 times 4. Okay, then LG 100. So we can write LG means logarithm to the base 10, 100. Then this can be written as logarithm to the base 10. 100 can be written as 10 to the power of 2. Then you can apply the power of a logarithm of a power. Then 2 times logarithm to the base 10. Then instead of this part, we can substitute 1. It's because there is a rule when when you have to find the value of particular number with the same base, answer is 1. And also there is another rule, the value of 1 to any base of a number is equals to 0. This is also very important when you solve the logarithm related question. Then here 2 times 1, answer is 2. Okay. For this one, you are given 2 marks. Let's move to the next question. Here it is, if logarithm or LG 10 times x, no, it is a product, is equals to b, then find the expression for LGX in terms of b. Let's see. First of all, let's separate this LG. 10 times x means LG 10 LGX, because I apply log rules. Apply log rules. When you apply log rules, product is separated as an addition equals to b. In the right hand side, it does not change. Then here LG10 means what? LG10. LG10 it is logarithm to the base 10. Logarithm of 10 to the base 10. The value is 1. The logarithm of a value to the same base equals to 1. Okay. Therefore, here it is 1. It is LGX plus B. Then LGX equals B minus 1. Now you have to find the LGX in terms of B. That means you have in terms of B. What is mean by this? In terms of B means you have to express using B or express particular thing using B. B use karala. Again, it may be an expression or a term. Definitely it should consist B. B තියෙන expression එකක් හරි term එකක් හරි තමයි in terms of B කිව්වහම අපිට answer එකක් හම්බ වෙන්නේ. Okay. Shall we move to the after 2012, in the 2015 they have given a question. Simplify. Here it is very simple question. It is actually 8th question in the paper 1 part 8. Part A, 8 question. Then logarithm of 9 to the base 3. The easiest way to find the answer is you can write this in index form. how you write this in index form? You can equate this to x. Then 9 is equals to 3 to the power of x. Then 9 can be written as the power of 3 as 3 to the power of 2. Then when you have an index equation with the same bases, therefore their indices are also equal. X equals to 2. Or there's another method to simplify this. It is logarithm of 9 to the base 3. This can be written as here logarithm to the base 3. 9 can be written as within this log term 3 to the power of 2. Then 2 is come front of here. Then 2 times logarithm of 3 to the base 3. Then logarithm of a particular value to the same base equals to 1. Therefore, it is 2 into 1. It is 2 here. Okay. In the both way, we can obtain the answer. So, here it is. Here 1 mark for the getting answer and applying any rule, 1 mark. Here also applying any rule, 1 mark. Obtaining answer, 1 mark. 2 marks are given. Okay. You can use either first method or the second method to obtain the answer. Okay. We have done this one here also. Okay, then 2016, the fourth question. Represent in index form. Very simple question. Logarithm of 16 to the base 2 equals to 4. Then to convert into index form, what you have to do? Take the or write the base. Base is 2. What is the index? Index is the answer of the log form. It is 2 to the power of 4 equals answer in the index form is written within the log term in log form. Then here you can obtain 2 marks at once. Okay. In the 2017, you have to express the value given in index form into log form. Then 3 to the power of 4 equals to 81. It is logarithm base is 3. Now, then base of the log form is also 3. The answer in the index form is written within the log term in the log form. Then it is equals to the index of the index form. Okay, the answer of the log form is equals to the index of the index form. Always remember it. Then this is also 2 marks given. Actually, the 2 questions in the 2017 and 2018 very easy. Okay. Then if you check the 2018 question, look at here, you can remember that in the beginning of this tutorial, I mentioned you that about the LG. LG means what? LG means logarithm to the base 10. Then it is a kind of question that they have used this particular short method. What is this? Here you have given the value of a particular power which is written to the base of 10. Then you are asked to find the LG 26.5. 3. That means actually when you write logarithm to the base 10, 26.3, answer is 1.42. No, because this is the index form, this is the log form. Then instead of logarithm to the base 10, we can write LG. Then LG 26.3 is equals to 1.42. Actually, to write the answer, you should know only this one. Then you are given 2 marks. Very simple question. Very simple thing that you should know here. Then in the 2019, this fourth question, if it is given that logarithm of a to the base 2 equals to 5, write the value of a as a power of 2. Then that means you have to convert this log form into index form. Then how we do? The base is 2, index is 5 is equals to a. Then a has been written as a power of 2. No need to find the value because you have to write it in as a power of 2. Okay. So the 2020th question is logarithm to the base, logarithm of b to the base a equals c. Then you have given the log form, then convert this into index form. Then base is a, index is c, then answer should be b. Then a to the power of c equals to b. Then the correct answer is second one, no? Very simple. Then in your exam also there will be such kind of question. Then easily you can obtain the answer if you know the log rules and if you know how to write the index form into log form and log form into index form. And also for the term test also you will have a such kind of question as a short question in the part A of the first paper. So you should have a good practice with these. Then very easily you will be able to obtain 2 marks for the logarithms. Then next time we are going to learn the logarithms related to grade 11. Okay, then thank you for your listening. Please comment and be ready for the next time quiz.